continue with the equation for estimating the earthwork. Earthwork volume. So when we do the earthwork to determine the volume, there are a few scenarios that we continue to explore. The first one is if we excavate one pit, how we determine that volume. So with that pit excavation, and for pit excavation to determine the volume equation, it will be, so basically we dig a hole to the soil. It will be the horizontal areas and time the depth of the cut or the excavation time the average depth. So that for the pit excavation, if we do the trench excavation, for example, we put a pipeline, water pipe, etc., the length is very great compared to, is much bigger than the width, then we are talking about trench excavation. So for this one, how we determine the volume? Very simple. Volume, it will be cross-sectional areas times the length. So cross-sectional area time the length of the trench. Now the if we really do the pit excavation with very big areas, how can we determine? Because as you can see, we talk about average depth for the pit excavation in the first equation here. But if it, the excavation depth is vary from point to point, how can we determine the average depth? That come to very cumbersome, and it need to take that into account when we excavate a large areas. And there is a equation so that we can determine the volume for excavating in the large areas. So large areas. So basically also pit excavation, but it's large. So how can we determine? We have to divide in the area, the horizontal areas of the excavation into a grid, right? Dividing the area into a grid, and that will show you in the next problem. Here, problem 3. So, and basically the pit excavation, but how we determine the horizon, the depth, the excavation cut, or the height of the excavation. So average depth in this case, how can I determine? So average depth in that case is equal to the depth at certain location on the grid. So it will be equal to the depth at any given point, and that, let me call that a point I times the weighting for that point. How we determine the weight, I will show in problem 3, and divide by the sum of all the weight for all the points that we have. volume on the weight. So the products, the sum of products, the depth at certain location times the weight of that location divided by sum of all the weight for all the points that we have. So with that, let's apply that in problem 3 here. And this is a big areas, a large area, and we want to find out the volume of the excavation. So basically this is the plan view of the excavation pit required for this area with the finger shown, and the finger at each grid intersection represent the depth. So the 6, for example, that is 6 feet, and in parentheses that will be converted into meter if we deal with the SI unit. So let's talk about the feet in here. 6 feet at the point top left, etc. So that show the depth of the cut at that location. And the depth in parentheses, like I said, represent the meter. So you can work either foot pound system or the SI unit. So let me work on the foot pound system in here. So this is a volume, and as you can see the equation in this is the peak we excavate going down and give you the depth and give you the areas, the horizontal, the in this case that is the length of the excavation areas, which is 400 feet, and the width, which is the vertical here, is 300 feet. So as you can see that are big areas, rectangle areas that we need to excavate, and we need to determine the volume. So apply the equation here. Pit excavation is equal to the area times the average depth. So how can I determine that? So let's write down the volume equal to horizontal areas times the average depth. And for this, the areas is mean the horizontal areas. So we have areas. We have the width 300 feet time 400 feet. You see a rectangles. So we have 120,000 square feet. So that is the areas. We have the first components. And then we want to determine the average depth. We need to use this equation. Sum of all the depth times weight divided by sum of all the weight. How can we determine? So with that grid here in square, you can see. And how can I determine the average depth? So for this one, we divide the grid, the point, into three type of point. You can see here. The first point, I say that is a corner point. That one is a corner point. Corner point. Okay. So those points, we need to find out what is the total depth of those corner points. So the first one, as you can see, corner point, and in this case you see the let's go from left, top left, and you go clockwise. So we have 6 feet. The second one 3.4 plus 2 plus 4.0. So from that we have 15.4 feet. So the total depth of the cut for those corner points, we have 15.4 feet. And then the second time of point that I want to point out, and I put that in let's see the blue here. So that we call it border points. Border point. Border. And as you can see, the point between the corner, it only have interface with only one pit, right? One grid in there with one rectangles. But for the border point, we have two. The one, for example, the 5.8, the point here, we have one angle there, one grid there, and one box in there. So that the weight will be different for the corner point and the border points. So that we have to treat them differently. So in that case, we have the border point. Also, we want to determine what is the total height or depth of all of these border points. How many of them? So we have 3, 6, and 10 of them. So just add on of the depth. So also go from left, top left, and clockwise. So I have 5.8, and then 5.2. Then we have 4.6. And then go to the vertical right, 3, 2.8, 3, 3.5, continue, 4.8, 4.8, and the last one is 5.5. So from that we can have 43.0 feet. And the last one is in the middle. As you can see at one point here, they have 4 corners. You see 4 corners for 4 rectangles here, and that, let me put that in the red. So basically that grid divide and get 3 different type of point: the borders, the corners, and then we also have interior point. And in the interior point, we will have 6 of them. So we can add on the depth, 5.0. Again, clockwise, we have 4.6, 4.2, 3.6, 4.0, 4.9. And this total, we get 26.3 feet. So that all the total depth of corner points, border point, and interior point. So when you have finished that step, we can go ahead to use this equation to determine the average depth. So from that we can have the average depth equal to the corner point 15.4 time, what is the weight? The weight here. What is the weight we need to determine? So the weight depends on the weight, basically the number that point have with the grid. So as you can see here, the border points is only one rectangles, one grid. So from that we can see the weight in there, it will be 1 for the corner points. Then we can continue with the total depth of the border points, 43 feet. And then time the weight. The weight in here for the border points, as you can see, there is 2 grid interface, so 2 pit. Then the weight, it will be 2. And similarly, if you can guess what is the weighting for the interior point, the total height 26.3 feet, what is the weight, 3 or 4? And as you can see in the interior point, we have 4 grid for that point. See that? Left, right, bottom, 4. So the weighting, it will be 4. So that is the first, the numerator for this equation, depth times weight, divided by the sum of all the weight. sum of all the weight. How can I determine sum of all the weight? So it will be the weight for the corner points is 1, but you have sum of all of them. How many corner points? 4, and you can see in green here, 4. So from that we can have 4 corner point times weighting of corner point 1 plus how many blue point or border point? 10. So we have plus 10 times the weighting for border point 2 plus how many interior points? 6. So we have 6 times 4. And when you add that, you can have the average depth of this one is 4.30 feet. So basically, the 4.30 feet, it represents the average depth of the whole excavation pit in this problem. So that we can now have areas and we have average depth, so we can be able to determine the volume of this excavation pit. So we have V is equal to area 120,000 square feet time average depth 4.30, and we want to change that into cubic yard, so divide by 27. So from that we can have 19,111 cubic yard. But keep in mind, in this case, the pit, the excavation, this is the geometry volume before you excavate at the natural condition. So the unit here, it should be BCY, bang cubic yard. So keep that in mind, because as you can see, you study in the first topic, soil volume change characteristic, bang cubic yard, loose cubic yard, compacted cubic yard are not the same. So with that, we done for the excavation of this.